A very good afternoon, everyone, and welcome back to this session. So, we are discussing something with respect to natural language processing. So, let's continue the same set of questions here. So, we all know that natural language processing, right? It is nothing but where we are trying to deal with the communication between we humans and the computers, right? So we can also say that it is a technique it is used right in AI, in machine learning, right, and it is also used to create some automated software, right, and it will help us to understand human spoken languages, to extract some useful information, right. It could be any form of data it receives, right. We are trying to extract some kind of information out of it. So the technique here will allow the system to process, to interpret data in the form of natural languages, right. As part of this only, we have understood the concept of stop words, right. Stop words are nothing but they are useless data, and that data which is not at all important, and we have to capture that unimportant, not important words, right, is just like useless data for a search engine, right. So there are many stop words like was, were, is, am, the, articles, many more. So we have to eliminate those stop words to understand, to analyze the exact meaning of the sentence. So the removal of stop words is one of the most important tasks for the search engines. So the algorithm has to be designed in such a way that they have to ignore the stop words. So this helps to show the relevant search result for any query, right? And also we have seen applications of NLP where the most famous your Google Translate chatbots, right? They are the very good real-time applications, I can say, for your natural language processing. So when Google Translate, one of the famous applications of NLP, right? It is what does it do actually? It will convert the spoken sentences or written sentences into any language, and also we can find the correct pronunciation and meaning of the word by using your Google Translate. So we can say that it is using the advanced technique of NLP, right? So that it becomes very good for translating into various languages from English to French, English to German, right? It could be any translation. And the most famous chatbots, right? It's nothing but a kind of customer support, we can say, right? The service provided by the customer. Like you have that what we call as the chatbots for 24/7 services. So basic queries, whatever the customer they have, that can be resolved using your chatbots. So if the chatbot is not able to resolve, sometimes it happens, right? It will not resolve any query, then it would forward that query to the support team, right? In this meanwhile also this what happens is that it engages the customer. So, and also we get a message, right? The customer executive would be reaching you out soon. Please wait for some time. He's quickly attending you. Please wait. So companies have become capable of building very good, I can say, cordial relationship with the customers. So this is also one of the real-time applications, right? Like you always get, once you open any of the websites, right, you get a pop-up coming up from a chatbot. Hi, how can I help you? Otherwise, it will even give you what you call it as the upcoming, if at all you are opening any training or consultancy website, any institute. So it pops up and it will ask you, right, these are our trainings, coming up trainings. Are you interested in, are you looking out for the same? Something like that, right? So in this scenario here, we were talking about some kind of analysis, right? We are talking about many kinds of analysis where we have understood syntactic analysis. So how can we understand syntactic analysis? So you are trying to analyze a sentence and you are trying to extract the exact meaning from it. So a machine can analyze, understand the order of the words, however it is arranged in a sentence. So it would employ kind of, if it like you can say grammar rules. So it is nothing but it helps in syntactic analysis of the combination and order of the words in the documents, right? So it is not a, it does many things as a part of this. Like you can start off with parsing, right? You have word segmentation, right? You have morphological segmentation, right? You have stemming and you have limitization. Right? We all know these are the basic things what you have to understand for syntactic analysis. The 5 things here. So in brief, I would like to know what is parsing, what is segmentation, what is morphological segmentation, etc. So when we say parsing, we'll not go into the depth of it, just on the top of it. So first thing is we want to know what is parsing. When we say parsing, it's nothing but it generally helps in deciding the structure of a sentence or text. It could be text in any document. So it will help you to analyze the words in text based on grammar language. Right? That is nothing but you can say that it is your parsing. Then you have word segmentation. So the word segmentation, we all are familiar with this word segmentation. The segmentation of the words would segregate the text into small significant units, right? Then what is this morphological segmentation? So this is nothing but it would break the words into their base form. Breaking the word segmentation is common, but breaking the words into their base form, in short, you can explain it like the purpose is to break the words into their base form. And already we have discussed what is stemming and what is limitization. Just orally we have discussed. So it's a process. Stemming is nothing but it would remove your suffix. Removing the suffix from a word to obtain root word, root word. Here, lemmatization, it would combine words using suffixes, and it would do in such a way that you're not altering the meaning of the word. It is, there's no alteration happening here, right? So this is all happens as a part of your syntactic analysis. But what about semantic? What happens in semantic analysis? What happens as a part of this? So now your aim here is you have to make a machine understand the meaning of the text. Machine should understand. We humans do many things, but even machine has to understand the meaning of the text. So various algorithms are there for the interpretation of words in sentences. So semantic analysis also, it uses various algorithms for interpretation of the words. So it also helps to understand the structure of a sentence. So what are the techniques you would for, or you can say that you will come across or you can apply as a part of this analysis is, I think yesterday we have understood the concept here. That is nothing but your named entity recognition. It is nothing but named entity recognition. You can also, one more is your word sense disambiguation. And your NLG, natural language generation. Right? In brief about all this. In brief about all this. So what is NER? We know that, right? It is a information retrieval. It will help to identify names, places, organizations, emotions, time, right? Everything. Word sense and disambiguation, it helps to identify the sense of a word. Sense, right? The name itself, you're understanding. It is a sense used in different sentences. And finally, your NLG. So that is a process which is used by the software. You are converting your structured data into human spoken languages. So by using NLG, organizations are automating the content and they are trying to get or pull the custom reports. Right? Pull the custom reports. Okay. Now, we are talking about tokenization, right? And we also know that the familiar library everyone are aware of is Nltk, right? Nltk is your Python library, and it is nothing but it's a natural language toolkit, and we use this to process data in the human language, human spoken language. So here, this Nltk is helping us to apply different techniques, right? Like parsing, tokenization, limitization, stemming, many things. And it also helps in categorizing the text, right? Analyzing the documents, etc. Like, this particular package, Nltk package, is it does many things. Like you have a unigram tagger, right? Regular expression tagger, trigram tagger, word net limmatizers, patterns, sequential back of taggers, many things we often use in NLP. Few of the things. right, from Nltk. This is very, very important. Now, I want to know to tokenize a sentence using Nltk package in Python. How do you tokenize? How do you tokenize a sentence? It could be anything you wish. You can write your sentence using Nltk package. Yeah. So you all know. Now what is tokenization? And the tokenize function is available in Nltk. I only told you that. So now how do you do that? So first of all, it is a process. It would split your sentence into tokens. And here I'm talking about sentence tokenizing. We are talking about sentence tokenization. So it is nothing but sentence tokenization is nothing but what is that? It refers to splitting a text into sentences. So we have to import sent underscore tokenize, right? From Nltk, you want to use tokenize, right? From Nltk dot tokenize. I want to import sent underscore tokenize. Right? Right? Sent underscore tokenize. So now let me write any question. Right? Text is equal to, right? I say hello everyone. I'll full stop. Okay. Welcome to let me write it as 360 TMG. Okay. And stop and I write this is interview preparation session. Right? Any mistakes here? Let's see. This is my text. Right? Now what I want to use? I should use a function called sent underscore tokenize. And what is it I should pass? I should pass text. Anyway, it is only English. I'm just passing it as text. Let's see. See here. Tokenizing a word is referring to splitting a sentence. Let's see every dot. Separate, separate, separate. Right? So this is nothing but you are using a sentence tokenize. Similarly, if at all you want to use a word tokenize, if at all you are using tokenize word, so from Nltk dot tokenize, I should import what is that? Simple word tokenize, word underscore tokenize. It's available readily. Right, let me run that. Okay, it is available. Okay, from this. So I will use same text. Okay, I'll write here now the function word underscore tokenize. So what is my question? This is my question. Text is my question. Okay, doing a tokenize. See here, you have, which is nothing but hello everyone, welcome 360 TMG. This, okay, I have written wrong. This is interpretation session. This is your interview preparation session. Right? Now, explain me now, right? I would like to know how do this stemming work, right? You know what is stemming. Now, explain me with the help of an example. Make it as let me write the previous question also. How to tokenize a sentence using Nltk. Now, with the help of an example, explain stemming process. Yeah. How do you start with? So stemming is what? It is a method to extract the root word by removing your suffixes and prefixes from a word. Right? You remove your suffixes, prefixes, whatever from a word. Right? The word stemming only is having ing words. You want to make it to stem. So we use various algorithms for implementing stemming, and one of them is what, friends? What is one that is available in Nltk only. From Nltk, there is something called as a stem. Nltk stemmers are there here, right? From that, you want to import, right? What stem? It's also there, right? I'm importing this. This is also available in my Nltk. Now, what I should do? Let me create an object for that. Right? Let me create an object PST. Yeah, I have this. This is done. So now how do I do that? I have PST small case dot. Let me use stem. The word I would like to give is anything. Okay, flying. Can I give this? Let's see why it's showing me. So it's giving me FLY. If I give PST.stem and the word should be cookies. COOKI. Right? It gave me It should be actually FLY, flying, but it gave me FLI. Right? And you can also try with one more word. It's running, jumping, it could be anything, right? This is your kind of stemming, right? Now, what is this? How do you do lemmatization? Yeah, what is lemmatization? So we are using both fronts. We are using stemming and lemmatization to extract the root words. However, stemming may not give the actual word, but whereas lemmatization should generate a meaningful word, right? Rather than just removing the suffix and the prefix, the process tries to find out the root word, right? And you have to get a proper meaning out of it, right? You have to get a proper meaning out of it. Now, how does it run? I would like to know how it is running. How do you do that? So I would like to pull from Nltk dot stem. Okay, what is that? We should import word net lematizer, right? Word net lematizer. Okay, this is what I want. Let me run this. Okay, now lematizer is equal to, I'll give an object now here. Let me create an object which is equal to the wordnet lematizer. Okay. Now let us write any sentence here. Any sentence. Okay. The sessions are going good. Good. By constant mentoring. Okay, this is more than enough. Two ing words are there, one s is there. Okay. Now what I should do? I'll just do once. I'll write an object. Sent underscore tokenized, which is equal to, I'll split it actually first. Send dot split. Okay. Right. Send dot split. So this is my sentence. This is my splitted one. Now what I should do? I'll use words, whatever the words I want. Lemmatization should be done. No, I will use the lemmatizer what I have created, object what I have created, right? From that I use lemmatize function, right? And I just say that take all the words, okay, and what you should do for the word, we should write one comprehensive statement here. For every word in sent underscore tokenized. Okay, this is what I'm doing. So what am I doing here? I'm using a limitizer what I have created, an object whatever I have created. From that, I'm using a function called as limitize word for every word in sent underscore tokenized. So my sent underscore tokenized, these are the words I'm asking you to do for every word. Okay, limitizer is not defined. So let me see the words. Sessions has become session. R is there. Going, good, constant, mentoring. Right? I can make any sentence. This is what your limitizer does. It tries to pick the exact word. Okay. Now right, you can create a list, and you can also show an example like that by using a wordnet limitizer. Right? You can show that. Now we have seen an example for limitization. Now let us see what is this, how do you explain this parts of speech tagging. What is this? What are parts of speech tagging? So yesterday we have discussed, right? It is nothing but they are nothing but the words where you will have a tag, whether it is a noun, whether it is an adjective, whether it is a verb, etc., etc. So here what it is doing, the software is using a POS tagging. It has to first read the text. It has to read the text. Then it has to differentiate the words by giving a tag to it. Right? So it's one of the most essential tool in NLP, and it helps to make this machine understand what is the meaning of the exact sentence. Right? So we can take or use stop words. POS tagging can be done using stop words because many stop words are also available in Nltk also. Right? So we will look to an implementation of POS tagging using stop words because you have to explain it, write the code. So anyway, we have an option of writing here. So we'll do this. Okay. So first, I need to import. Let me write it. POS tagging. Many ways are there. You can opt any of these things. I'm showing you the basic thing here. Basic way of writing or pulling the tags. POS tagging. Okay. So we know that from nltk.corpus, right? We have come across this nltk.corpus. You can import stop words which are given by NLTK. We know that, right? And okay, then from NLTK only, right? We need to do tagging. So in order to do tagging, first we have to do tokenization for the words. So let us pull even the tokenization. tokenize function. Okay, so I would like to import word underscore tokenize comma sentence underscore tokenize. Okay, let us see. Can I run all the three at a time? I'll run it. Yeah, all the three are available. Now, when you want to pull a stop words, no? So first we'll write stop words. Right, stop words. Okay, let us make it. Okay, which is equal to, you are setting the stop words. Which stop words, friends? We would take English stop words because we'll give a sentence which is English. From that you have words and take English. Okay, this is done. Let me run this and making it into a set. Yeah, I have the stop words. Okay, which are from Nltk. Now let me write the question. Any sentence. Okay, right? Okay, let me write my name. Okay. Right? They are friends. Okay. This is my text. Okay. So first what I do, I will make one tokenized. I will make one tokenized underscore text. Okay. What is that? I should do sentence underscore tokenize function. English is only, I know that, and I should write my question. So what I get here, I'm getting my tokenized text, sentence tokenizer. Okay, that is done. Now what I should do, for every word in my tokenized text, I should make into a word tokenizer, right? And then I should check whether that particular word is there in my stop words or not, right? Then I should use tag words to pull the tag here. So let me write a for loop here for n in tokenized text. Okay, it's underscore, no? That's what's showing me an error, and I ended the colon, and I write words list. Okay, I'm making it. We all know that Nltk dot words underscore word underscore tokenize. N words. Right? Nltk dot word underscore tokenize. Anything is wrong here? Yeah, done. Right? And now whatever I have here in my words list, what I do, I write a list comprehension here using a for loop. I'll write W for W in my words list. If not, W in, what is that? Stop words. Okay, I made it stop underscore words. So I use stop underscore words. right? W for W. Every word, check the every word in my words list. If not W in stop words, then only pull it out. Okay, this is what I have written. Now I have to get the tagged words. I should get the tagged words. So tagged words is nothing but, I think I have it because I did not install it. POS underscore tag. Nltk.pos underscore tag. Yeah, I have it. So words. See, I want the tokens. So I'm having what my words list. Right? If I use this, it's not coming. Okay, this is what I have. Let us run. Okay, let me run everything at once. So I want to print my tagged words. See here. Friends, it has taken NNS. All the names it has taken NNP. Good, it did not take anything. Right? This is called as your POS tagging. I don't know why. Okay, good, it is JJ. Friends, it is NNS. So that will good nothing. It took JJ. And all other are names, no? It has taken that. Now this is nothing but your what you say as your POS tagging. Okay, so we are talking about so many components, right? In that components, we are trying to understand the every analysis, what is the procedure, because yesterday also when we were discussing different terminologies as a part of our training and as a part of our NLP, right? So different terminologies are there. So one of the most often asked question in the interview is like not define what are the new things or the terminology related to NLP, right? So the interpretation of NLP processing, it depends upon various factors, like if you can make it into a different statement like thing. So we can say interpretation of NLP. What are they? Right? First one, I can say it is nothing but your weight sign vectors. So in this again, what you use, you have many things. You use your TF-IDF, use of TF-IDF, the length of TF-IDF in the document, and you use word vectors, Google word vectors. There is one point. Then you go for structure, right? Then you have to see the structure of your text. Right? In this again you see your POS tagging, head of the sentence, the title, the name, identity recognition, all this. Then you will also have to see the sentiment analysis. Right? It is nothing but trying to pull the characteristics of the sentiment. Knowledge about the entities, right? And you should have a common dictionary which is available for sentiment analysis. Then you do classification of text, right? So you will try to have a training set, you have validation set, test set, features of the text, and you do LDA. latent detted allocation. So all these are coming one after the other, one after the other. So as a part of this question, one more question which people directly, the next question would be like, what is the difference between your NLP and NLU, right? NLP and NLU. So we are keep on discussing. It is used to create NLP is nothing but you are trying to establish communication between humans and computers. I keep on saying it from the start. So whatever techniques are required for the interaction between machine and humans is happening under NLP. Now, what is happening in NLU? So, NLU is nothing but natural language understanding, where it is providing techniques to solve some complicated problems where the machine would feel like difficulty in understanding. Right? It will help to convert the unorganized the data, right? And that unorganized data, definitely textual data is unorganized and unstructured. So you have to convert it into a structured format and then make the machine to understand the data, right? So that is a one basic difference, right? What you can see as a part of your NLP and NLU, right? So, and what steps, right? What steps are involved as a part, when you're trying to solve any NLP problem? That is also one of the, frequently or most famous question in solving an NLP problem. What is that actually? What are the steps here? So first you're trying to start with gathering the text, right? Maybe from different sources, from, okay, we can make it as available data set, right? Or you're doing web scraping. We know that we have done it, right? Then you apply data cleansing techniques. So what are the data cleansing techniques? The most famous: stemming and lemmatization. Okay. Yeah. Then what did we do? You would apply feature engineering, right? You will apply feature engineering techniques and you will then embed using word to vec, right? Then you can train your model or train the model, whatever you have built, using neural networks, right? Using neural networks or any other, okay, or any ML algorithms. And also finally, now you evaluate the model performance and you'll not sit quiet, right? You have to make appropriate changes. Changes to the model And finally, deployment. Right? Finally, you are doing deployment. Right? These are the things what you do. Now, when you are talking about feature engineering, what do you mean by feature extraction in NLP? What is feature extraction in NLP? So features are nothing but the characteristics of a word, right? And words in a text or a document, whatever it might be. Right? So by understanding or deep diving into the characteristics of a word, right, they also help in sentiment analysis of the text. So we have also uh, come across this particular tag, the feature extraction, as a part of our recommendation systems. Right? We have come across this as a part of our recommendation systems, where we are trying to identify the feature of the text, and that feature will help you to pull or identify or describe what is at what context that particular word or a sentence is used, right? So that it makes a group or category of words that have some common meaning, common characteristics, right? That is how it learns by itself. So whenever a new word comes in, right, the system already which is categorized the words, right, according to the labels, whatever already it is created, it would put into that particular label, right? It categorizes it as per the labels of the respective groups. So here we are saying that you are trying to evaluate a model performance. So we have understood feature extraction is something it has to understand, like the reviews, whatever we are giving, right? People write excellent, worst, good, great, right? So these are the reviews what we have to recognize, right? It is nothing but now all are positive reviews. Worst is a negative review, right? So recommended system also tries to identify the feature of the text and will help us to understand in what context that particular words are being used. Okay, this is one thing. We are trying to apply the feature engineering techniques. Many things when coming to picture. Now, how do you evaluate your model performance? Is it the same or is it different for NLP or for textual data? What is that? Wow, how do you are trying to evaluate here? See, we all know that the metrics used to test an NLP model. If I ask you in that way, right? Metrics used to test NLP model. What are they? You have to check the thing, right? The metrics is nothing but a precision and recall, right? You would check, you take precision and recall. And also I forgot this F1, right? And these three. And also we use accuracy for evaluating the model's performance, and the ratio of the prediction and the desired output, it would yield the accuracy of the model. So when we say precision, it's nothing but your true positive by true positive plus false positive. It is nothing but you can write it as what you call it as true positive by total predicted positive. Right? This is nothing but what you get as a part of your classification report. Right? Then this is your precision. When you talk about recall, it is nothing but your true positive by total actually positive. Right? This is your recall. Now what is this F1 then? F1 score in NLP. 3 metrics, no? I told you 3. So F1, what is F1 here? What does it evaluate? Okay. It is nothing but, it has to, it evaluates, I can say, the weighted, is, I'll write the formula directly. So it's nothing but the weighted average of recall and precision. Okay, it is a weighted average of recall and precision. Right, first thing is that. So it considers both false negatives and false positive instances while evaluating the model. So F1 score is more accountable than accuracy of your NLP model when there is uneven distribution of the class. Right? When you have uneven distribution of the class. So let us see the formula here. 2 into the same what you get as a part of your normal ML algorithms by precision plus recall. And this is your F1 score in your NLP. Right? Okay. So we'll stop here. And thank you so much for joining the session. Thank you. So we could cover few things as a part of NLP. So people do ask you, write a simple code for stemming, write a simple code for POS tagging, write a simple code using Nltk library, and how do you pull unigram, bigram, and trigrams in NLP, right? So as I showed you, POC tags and limitizer, pot stemmer, potter stemmer, and all that. You should even try to write a simple lines of code for these, right? Okay, like name entity recognition, how do you implement it, right? And how do you implement lemmatization for using a list of words instead of a sentence, right? So these are the things what you have to practice more. Okay, so thank you all for joining the session. Thanks. We'll connect tomorrow, same time. Thank you.